Welcome to my lessons. Today's our topic Euclid's division algorithm. In my previous video, I have explained Euclid's division lemma. Don't be confused, both are not same but related. The word algorithm, it means it's a process or a set of well-defined rules to be followed in a calculation or in a problem-solving operation. Likewise, Euclid's division algorithm also a technique to find out HCF of given positive integers. Right? Now, I am not going to concentrate on the problem solving, but I'd like to explain you more on the justification of Euclid's division algorithm, why it works and how the HCF found by Euclid's division algorithm will be appropriate. Right? Because I am choosing the justification part, it may be little bit more, but here my word of advice is understanding this type of justifications is a good mental exercise and it will improve the ability of your logical thinking and it improves the educational standard of reasoning and proof. So don't skip the video, please watch till the end. Now let us take an example problem with the solution. Now it is the problem, find HCF of 320 and 132 using Euclid's division algorithm. This is the problem and here we have the solution also. Here we can observe there are 5 steps, 1, 2, 3, 4 and 5. Finally we got output 4, that is the HCF. Then what about the input? The input is 320 and 132. For the first step, the input is obtained by the problem. And for the second step, the input is obtained from the first step. Likewise, we have taken the input for the last step from the last second step. Right? This type of step-by-step procedure, obtaining input from the previous step is nothing but algorithm. And at every step, we have applied Euclid's division lemma. That is the reason behind we call this procedure as Euclid's division algorithm. Now come to the justification part. Before going to that, just we need to recall once the statement of Euclid's division lemma. Euclid's division lemma. Given positive integers a and b, there exists unique pair of integers q and r, satisfying a is equal to b plus r, where 0 is less than r is less 0 is less than or equal to r is less than b. You might have observed some important facts regarding this concept, like a is greater than b and b is greater than r. One more important fact right now we should have to observe, I'll tell you. Any common factor of a and b must also be a factor for r. If any doubt regarding this, please comment, I will give you more explanation. I repeat, any common factor of a and b, it must also be a factor for r. That means the three a, b and r having the same factors in common. Let us supposing that x, y, z be the factors for a and b. Therefore, the same x, y, z must also be factors for b and r. If x is the highest among these x, y, z, then the HCF of a and b is equal to x. Similarly, the HCF of b and r also the same x. Now we can come to a conclusion. In short, by applying Euclid's division lemma, a is equal to bq plus r, where 0 is less than or equal to r is less than b, if here the r is equal to 0, that means the divisor, that b is a factor of a. That means the HCF of a and b is equal to b. Right? If r is not equal to 0, then we can say that HCF of a and b is equal to the HCF of b and r. Now we should use this conclusion in our justification, right? Now come to the problem again. Here, what is the target? Our target is finding HCF of 320 and 132. So, from the first step, it is clear that HCF of 320 and 132 is equal to the same as the HCF of 132 and 56. So, the first step gives an idea that instead of finding the HCF 320 and 132, we can find the HCF of 132 and 56, right? Likewise, the second step also gives the same idea. Instead of finding the HCF of 132 and 56, it is enough to find out the HCF of 56 and 20, right? Likewise, from the last step, it is clear that we have to find out HCF of 320 and 132. It is enough to find the HCF of 16 and 4. At the last step, the remainder is 0. That means it is clear the HCF of 16 and 4 is 4. Therefore, the HCF of 320 and 132 or the HCF of 132 and 56 or the HCF of 56 and 20 or the HCF of 20 and 16 are the same. Is it clear? Right. Now, from the last second step, the remainder is the HCF. Of course, it is the same as the revised at the last step, but I suggest my students to write the remainder from the last second step as the HCF, because I have observed so many students confused for writing the result. For example, 12 is equal to 3 to 4 plus 0. So many students write the HCF as 4 instead of writing 3. All of a sudden confusion, right? So I suggest you take the remainder from the last second step as the HCF. I hope it is clear. Thank you for watching. Please subscribe my channel.